In Module 3, we looked at working with null values. In this module, we're going to expand on that, and we're going to take a look at how null values and missing data impacts our SQL selects. In the next section of this exercise, we're going to take a look at working with tables where null data exists or our joins result in data being returned that is null. The Chinook database doesn't give us a lot of opportunity to work with missing or null data. So we're going to create a new table called Track Composer. We'll go ahead and highlight the SQL statement that creates this table and hit execute. Notice that under the create table, we've defined each column inside that table. Composer ID, for example, is an integer and not null. Notice website is a varchar, and it does allow null values. It is very important when you're designing tables in a SQL database that you decide up front which columns you're going to allow to be null and which columns that you do not want to be null. Now we need to add data to our table. So let's go ahead, highlight the insert into statement and hit execute. This will insert a row of data into our table. I can verify that by doing a select star from my track table and seeing the entry that's been added to our table. Now I'm going to execute 3 different select statements. Essentially, all 3 will do the same thing. And we're highlighting the fact that since I only have one track composer in my track composer table, when I join it with my track table, I will only return those records where the track composer is AC/DC. Now, highlighting and executing the second and the third variation off of the SQL statement. Next, I'm highlighting 2 SQL statements. The first SQL statement is doing an update to our track composer table. We'll talk more about the update later. The second statement's the one that we want to focus on. This statement is doing a left join of our track composer table and the track table. The left join tells SQL, take all members from the track table and combine it with data found in our track composer table. Notice in our result set, since track composer did not contain all of the composers in our track table, we returned quite a few null values. Our second SQL statement cleans this up a little bit. We take a look at the result set and data from the track composer table that's returning a null value. We're looking at that and we're saying if the value is null, let's put in an A for not applicable. This will make the data easier for us to use moving forward. Now let's take a look at handling null values in our where clause. In prior examples, we showed how using a left join would allow us to show all records from a table that may not necessarily have had a link into another table. But now I want to do that same join, but I want to eliminate records where the composer is null. Notice in the next SQL statement, we've included an additional where clause, where composer is not null. This criteria will eliminate those records where the composer is not populated. In the last SQL statement, we added an additional criteria to our where clause, where website is not null. Executing this statement, we see that our result set looks exactly the same as the result set we got when we didn't do our left join. The key to handling missing or null data is understanding the difference between these 2 SQL statements. The first SQL statement is a simple join, where nulls don't evaluate to true, so they are eliminated from the result set. The second statement is more complex, but the result evaluates to the same set. Let's take a closer look at our second SQL statement. The from clause defines a left outer join, which determines that all records from our track table will be returned in our result set. The join on the track composer table means that the intersection of the 2 will return all related track composer information. The where clause is where this statement gets to be a little interesting. Notice that the where clause is outside of the join criteria. That tells us that the filter in the where applies to the entire join result set. The where clause itself says remove any records from the track table where the composer name is null. This could have been any valid limiting criteria against the track table. The next part of this says website is not null. This acts against the entire join and limits the result set to only those records where there is a website populated. Considering the data that we have in our track composer table, we now understand that AC/DC is the only composer that we have a website listed. So now in our second statement, it's the only one that is returned. There's another important technique that we can learn from these two SQL statements. In the first statement, nulls are removed since they do not evaluate to true. In the second SQL statement, we're specifically handling the null cases, and nulls are removed since they evaluate to false. We could also write other SQL statements where we include results where null evaluates to true. This is the end of this presentation.